If GPS failed during World War III, the first thing you might notice is that maps, ships, aircraft, and drones would suddenly stop knowing exactly where they are. It works by timing. Satellites orbiting Earth constantly broadcast the exact time and their position, and your receiver compares signals from several satellites at once. By measuring tiny differences in when each signal arrives, it calculates your position on the planet. The problem is that those satellite signals are extremely weak by the time they reach Earth. They travel thousands of miles through space and arrive at your antenna weaker than many background radio noises around you. In a major war, enemies would try to attack that weakness. One of the easiest ways is jamming. A jammer does not need to destroy a satellite. It only has to flood an area with stronger radio noise on the same frequencies, so GPS receivers can no longer hear the real signal clearly. Once that happens, phones may freeze on old locations, drones may lose their navigation path, and ships or aircraft may have to switch to backup systems. But jamming is only the simple version. A more dangerous attack is spoofing. Instead of blocking GPS, a spoofing system sends fake satellite-like signals that look real to the receiver. If those fake signals are stronger than the real ones, the receiver can be tricked into calculating the wrong position. A drone could think it is flying over one area, while a ship could slowly be pulled off course without the crew noticing right away. During a world war, GPS satellites themselves could also become targets. An enemy might try to blind them with lasers, disrupt their control links, attack ground stations, or even damage satellites in orbit. Even losing a few satellites would not instantly erase GPS everywhere, but it could create weak coverage, lower accuracy, and more vulnerable regions. The bigger danger is that GPS is not only used for directions, it also provides precise timing. Power grids, cell towers, banking systems to stop. If that time became unreliable, systems that seem unrelated to navigation could start failing. This could make modern warfare feel suddenly less precise. Armies would not be completely helpless. And the scariest part is that the failure might not look like everything going dark. If World War III started, satellites would probably become some of the first targets, because modern armies depend on space before a single vehicle moves. Satellites are not just floating cameras. They help countries navigate, communicate, track weather, guide weapons, detect missile launches, and watch troop movements from above. A commander looking at a battlefield map may seem like they are using a normal screen, but behind that screen are satellites feeding timing, images, signals, and location data down to Earth. The reason they matter so much is distance. A satellite can see huge areas at once, including oceans, deserts, borders, and remote bases that would be hard to monitor from the ground. Reconnaissance satellites can spot ships leaving port, aircraft moving on runways, missile launchers changing position, can connect forces across continents when normal towers or cables are destroyed. Navigation satellites can keep drones, aircraft, missiles, ships, and soldiers aligned to the same invisible grid. So in a major war, attacking satellites would be a way to blind and confuse the enemy before larger strikes begin. If surveillance satellites are disrupted, commanders lose part of their view of the battlefield. If communication satellites are jammed, units may struggle to receive orders or share updates. Satellites are not just floating cameras. They help countries navigate, communicate, track weather, guide weapons, detect missile launches, and watch troop movements from above. The first attacks would not always look like explosions in space. Some would be electronic. Ground-based jammers could blast strong radio noise towards satellite signals, drowning out the weak transmissions before they reach receivers. Spoofers could send fake signals that make a drone, ship, or weapon believe it is somewhere else. Cyber attacks could target the ground stations that control satellites, disrupting commands, delaying updates, or cutting operators off from their spacecraft. But if the war became more intense, countries might also use harder attacks. The problem is that destroying satellites can create clouds of debris moving faster than bullets.
That danger affects more than the military. Armies would still have backups. And whoever loses that layer may still be fighting.
If World War III spread across the oceans, submarines could become some of the hardest machines on Earth to find. A submarine is not hiding because it is small. It is hiding because the ocean is enormous, dark, layered, and full of natural noise. Once a submarine dives deep enough, satellites cannot see it, radar cannot reach it, and normal cameras become useless. The only reliable way to hunt it is usually by sound. That is why submarines are built around silence. Every pump, fan, motor, pipe, and moving part has to be isolated so it does not vibrate through the hull. Even the crew has to follow strict sound discipline, because underwater sound can travel for miles. A drop tool, a loud valve, or a sudden speed change can create a clue for enemy sonar. So when a submarine wants to disappear, it slows down, reduces machinery noise, and moves like a shadow through the water. The ocean itself helps hide it. Water is not the same temperature everywhere. It forms layers, where warmer and colder water bends sound in different directions. A submarine can slip below or between these layers, making sonar waves curve away, scatter, or return confusing echoes. Deep water, rough seas, animal sounds, ship engines, and shifting currents all add background noise, which makes one quiet submarine much harder to separate from the ocean around it. During World War III, patrol ships, aircraft, drones, and underwater sensors would search for these tiny clues. They might drop sonar buoys, listen for propeller noise, scan magnetic changes, or track heat and wake patterns near the surface. But a hidden submarine does not have it only has to avoid giving away a clean pattern. Nuclear submarines can stay hidden for months because they do not need oxygen to run an engine like diesel submarines do. Their nuclear reactor creates heat, which makes steam, which turns turbines and generates power for. Since the reactor can run for years without refueling, the real limits are usually food, maintenance, crew endurance, and missional orders. Fuel. Oxygen can be produced by splitting water into hydrogen and oxygen, while carbon dioxide is chemical fibers. No sunlight, the derivatives is circuit. If World War III was getting close, cyber attacks could begin before the first missile is ever launched, because digital systems are easier to reach quietly than physical targets. A missile strike is visible, loud, and impossible to hide once it happens. But a cyber attack can start as a fake email, a stolen password, a compromised software update, or hidden code placed inside a network weeks or months earlier. By the time people notice something is wrong, the first stage of the attack may already be finished. The reason this matters is that modern countries run on connected systems. Power grids, ports, banks, airports, fuel pipelines, satellites, hospitals, cell towers, military bases, and command centers. In war, or it creates invisible doors that an enemy may try to open before the fighting officially starts. Power grids, ports, banks, airports, fuel pipelines, satellites, hospitals, cell towers, military bases, and command centers. In war, or it creates invisible doors that an enemy may try to open before the fighting officially starts. They would not always try to destroy everything immediately. First, they would map the network, look for weak points, steal access, and quietly test which systems they can reach. Once attackers get inside, they may leave behind malware designed to wait. This kind of hidden access can sit quietly until it receives a command, or until a specific date, signal, or emergency condition triggers it. That means a country could be preparing the battlefield without moving troops or launching aircraft. The goal is not just to break computers. The goal is to create confusion at the exact moment leaders need clear information.
If a major crisis begins, those hidden tools could be activated all at once. Power stations might suddenly lose control signals, train schedules could freeze, ports could stop tracking containers.
Cell networks could overload, banking systems could delay payments or lock accounts. None of these failures need to look like an attack at first. They might look like glitches, accidents, or normal technical problems happening at the worst possible time. For the military, the effects could be even more dangerous. Commanders need communications, satellite links, radar feeds, logistics databases, navigation systems, and fuel supplies to work together. If cyber attacks disrupt those systems before missiles fly, units may receive delayed orders, aircraft may wait for fuel records, ships may lose port data. If a global war broke out, cities could go dark long before every building is physically damaged, because modern cities depend on one giant electrical chain working perfectly. Power has to be generated, balanced, transmitted, stepped down, and delivered through thousands of wires, substations, transformers, control rooms, fuel systems, and digital sensors. When that chain is stable, lights turn on instantly. But when even one major section is attacked or disconnected, the failure can spread faster than most people expect. The first target would likely be the power grid itself. An enemy could try to hit power plants, substations, control centers, transmission lines, or the fuel systems that keep generators running. But the attack would not always be explosive. Cyber attacks could enter grid control networks and make operators see wrong data. Jamming could disrupt communications between power stations. Satellites and timing systems could be attacked, making coordination harder. If operators cannot trust what the grid is showing them, they may shut sections down on purpose. Power grids are fragile because electricity has to be balanced in real time. The amount being produced must closely match the amount being used. Other stations have to compensate immediately. If they cannot, protective systems trip offline to prevent equipment from melting or catching fire. This can create a domino effect where one overloaded line shuts down, then the next line carries too much power, then another transformer fails, and entire neighborhoods lose electricity. Large transformers are especially dangerous weak points. They are massive, expensive, difficult to move, and not easy to replace quickly during a war. Substations are just as important because they step high voltage power down into levels homes, hospitals, cell towers, pumps, and traffic systems can use. Once the city loses power, cell towers switch to backup batteries, but those may only last hours if fuel trucks cannot reach generator sites. Internet routers, payment systems, ATMs, gas pumps, and store scanners can stop working. Hospitals and emergency centers have backup generators, but those systems depend on fuel, maintenance, and working supply routes. Water treatment plants also need electricity to pump, clean, and pressurize water.